Hello, and welcome to this session on using Ansible with Checkpoint APIs. I'm your host, Dwayne, and I appreciate you having me here today. In this episode, you'll learn about Ansible Playbooks and the Checkpoint modules. We'll dissect a playbook to discuss the individual components so you have a solid understanding. You'll learn about Ansible modules in general and the Checkpoint module specifically. I'll show how the modules correspond to their management API commands. In the second half, you will build 2 working playbooks to see these modules in action so you can follow along at home. So grab yourself a snack, a beverage, and let's get started. Now we're going to play with playbooks. Ansible is a non-interactive process, so all operations are carried out automatically in an organized manner. Ansible handles the connection and login methods to the host targets. In our case, this target is the Checkpoint Management API server. The instruction code for Ansible is in the form of a playbook. A playbook contains a list of parameters and tasks, all of which is written in YAML. Now you'll start building your playbooks piece by piece. A playbook contains an order list of sequences called plays. A playbook can actually contain more than one play, but to get started, our playbooks will contain just one play. For the multi-domain folks, your playbooks definitely will have multiple plays. We'll get to those in the MDS episode later. A quick note about syntax. There is no attribute or item explicitly named play. A play is just an instantiated construct within the file for your playbook. Don't get too confused and don't spend time searching for a keyword by that name. It's not there. Our playbooks will have 3 main sections: header, variables, and tasks. The header section for our playbooks will contain these 3 items: name, host, and connection. For name, all plays should have a name. The play name will show on the console output as well as in a log file. Always name your plays. For hosts, this is a collection of hosts from the inventory. This can be a single inventory host or an inventory group. For MDS, you will use the inventory host for your management domain, including the global domain or the MDS root itself. For the connection, this is the network connection method. For us, this will always be httpapi. http API means an HTTPS connection to the API server. You must always specify the connection method. The variable section would be one or both of these items, vars and vars_files. For vars, these are the variables specific to this play. This is a dictionary of variables. Each variable can be any legal YAML data type. Vars files is a list of external variable files not necessarily specific to this play or sequence. The vars files variable itself is a YAML list. You'll see examples of this shortly and why I do this. The tasks section is a list of specific tasks to execute. This is a YAML list. Each task has the same basic structure, a name, and a module name. Each task should have a name. Like the play name, this also appears on the console output and in a log file. The module name will be the specific module to load and execute. Each module has its own set of parameters. You will have to read through each specific module's documentation to learn these parameters, but eventually you will learn them from memory. Be patient as you go through this. There is no shortcut. Tasks can contain other items like conditional qualifiers, flow control mechanisms, and even loops. We'll go over these items in upcoming episodes. Okay, that covers the basic anatomy of playbooks. Now we'll dig into the structure of a checkpoint module. This is the Checkpoint Management API reference, and here I'm showing the API commands for the host objects. Each checkpoint module maps to a management API command. Most APIs have these basic verbs: show, add, set, and delete. The API show command has both singular and plural command versions. The singular command retrieves one object. The plural command retrieves many objects. This is probably obvious, but I wanted to point out the difference. You will need to know the specific object type to specify the correct checkpoint module in the task list for that object. To map the modules to API commands, 2 Ansible modules are available for each object type. A fax module maps to the API show command. An individual object module maps to the API add, set, and delete commands. What are facts? Facts are Ansible's method of collecting attributes for a remote host. or in our case, an object on the management server. This is how Ansible learns about things. Facts are stored in a dictionary variable named Ansible_facts. A facts module can accept an optional name parameter. Without a name parameter, the facts module maps to the plural API show command to retrieve many objects. When given the name parameter, the module maps to the singular show command to retrieve one object. Either way, the result is stored in the Ansible facts dictionary with a key named for the object type. For a single object, the object's key value is the dictionary of the object's attributes. For many objects, the key's value contains an object's key, whose value in turn is a list of objects. For all other operations, the object module is used to add, set, or delete the object. For the object module, the name parameter is usually the only required parameter. Why is this? Any module adheres to Ansible's principle of idempotency. Idempotency means no matter how many times the module or task is ran, it produces the same result. If the object does not exist, it is created with the specified parameters. If the object does exist, it is either updated to the specified parameters or it is unchanged, depending on its original state. To achieve idempotency, some attribute must be unique for a before and after comparison. For checkpoint modules, this unique parameter is the name attribute. But how does the module know to add, set, or delete the object if only one object module is available for all three APIs? An optional parameter, state, makes that determination. The state parameter has two possible values, absent or present. Absent says to delete the object if it exists. Present says to create the object if it doesn't exist, or to update it if it does exist. Each module is atomic. The module does the hard work for you to figure out if the object exists or not. You don't have to worry about those specific details. If the object exists, the module will know to use the set API. If the object doesn't exist, the module knows to use the add API. With state absent, the module will know if the object exists to be deleted. That covers the basic anatomy of playbooks and modules. Now we'll build those two playbooks as promised to see some of these modules in action. Keeping with the theme, we'll discuss the physiology of playbooks and modules as we go along. Alright, here's our first playbook. This part is going to go a little slow because there's a lot of new stuff to cover. This is the only time I will cover these new items, however. After this, we will go much quicker. Remember that a playbook is written in YAML, so we'll follow YAML syntax guidelines and start with the YAML opening markers and end the document with the YAML closing markers. At the top is the header section, as you've already seen. The play is given a name and the host is specified as the checkpoint management group from the inventory we built in an earlier episode. The connection type is always httpapi. Now the vars section. This was omitted earlier. Although you have several choices on how to supply play-specific variables, for this demonstration, I'm writing these next two variables here on purpose because we haven't talked about how to access variables yet. That's coming up in the next episode. One thing at a time. The first variable is Ansible Network OS. I strongly encourage you to use this as a play-specific variable. This means you will write this variable in every play rather than store it in the inventory. Doing this is going to be annoying at first, but when we get to the Gaia API episode, it will become incredibly obvious why, so make this play specific. For management API, the value is always checkpoint.mgmt.checkpoint. Seems like there's redundancy in this, but it actually has meaning. This is what Ansible calls the Fully Qualified Collection Name, or FQCN. The first part, check_point, 2 words, is the namespace. Kind of like a domain name for the collection, this is often the vendor name. The second part, MGMT, is the collection name, which is the bundle containing the modules and any auxiliary items. Checkpoint, 1 word, at the end refers to the name of the plugin inside the module collection. This is where the connection type HTTP API in the header section above knows to look for the plugin that handles all of the dirty, ugly REST API sessions to the management server. This Ansible Network OS line is the magic glue between Ansible and the management API server. Do not leave this line out. The next variable is Ansible API key. This is the API key for the dedicated Ansible admin you made in SmartConsole back in the first episode. You did save that API key to your password manager, right? Or at least in Notepad? A sticky note under your keyboard? Ah, excellent. Paste that key here. I wrap my API key string in quotes out of an abundance of caution. I don't want to take a chance on some wild character getting misinterpreted, like that / you see there. For those of you whose API server is on an alternate port, you need an additional variable. You need to add Ansible HTTP API port and the port number. The port number is an integer, so write it that way. No need for quotes. You can store this variable in your inventory if you want. This does not have to be place specific. For you Smart One Cloud folks out there, your Infinity Portal tenant ID is already in your inventory from when we built that in the second episode. Nothing further for you to do here. Now we move on to the tasks section where the fun stuff lives. Remember, the tasks section is just a YAML list itself, so we have to pay attention to the levels of indentation. If you see other playbooks on the internet, you'll see that some folks start their list indentations at the same level as the tasks keyword. This is allowed, but it's technically not correct. The best and most correct way is to indent one level further than the list variable name. There's another reason why, which we'll see in several episodes from now. For our first simple demo, we'll pull a list of host objects from the management server. This may make you nervous if your server has 5,000 host objects or so. Don't worry, the API server knows not to serve you a fire hose full of data. By default, the API server will only return the first 50 objects. Each task has a name. Name your tasks. You'll be glad you did. The first task is to call the host facts module. The FQCN format is used, which is the same as we saw in the Ansible Network OS variable above. The specific module is the last part of the FQCN. There's a task keyword we haven't discussed yet, register. Register is Ansible's way of assigning the module's results to a variable. You can name the variable anything you want within legal limits, but you can't use an existing Ansible reserved word. Once assigned, you can use this variable like any other to parse and process the output of the module. You'll see many more ways to do this in the next episode and beyond. Okay, the first task is complete. Very short, very simple. Get the host objects. Each task in the task list is actually a dictionary. Yes, a list of dictionaries. Not all dictionary keys will have values, however. The module is specified as a dictionary key, but it has no further values. The register keyword is not a parameter of the module. Notice, a name parameter was not given to the host facts module. Name here is the name of the task. Since the module was not given any other parameters, it will use the plural version of the show hosts API, which retrieves many objects. Remember, each module is atomic. That one module does that one thing and only that one thing. We need a second task to do the second thing. To display any output of any kind to the console, Ansible uses the debug module. This is a built-in module provided by Ansible. So the FQCN for this is the Ansible namespace and the collection named built-in, and the module name is debug. Debug can take a few different parameters, but the one we will use for simplicity is the var parameter. This tells debug to dump the entire contents of the specified variable. In this case, it's the name of the variable registered to hold the output of the host facts module. End this YAML document with the closing notation and be sure to add a new line at the end. Now let's run this playbook and see what happens. I'm going to switch to my terminal app now to run the playbook. I'm using Docker on my MacBook, so I'll prefix my commands with those options. If you're running yours natively under Linux or Mac, then you can skip all of that and just use the Ansible Playbook command here at the end. For a quick Docker run through, my command line says, run a Docker container from an image, allocate a TTY, which lets Ansible show colorized output, remove the container when the command is done, map a folder on my Mac into the container, add a volume location, change the initial working directory of the container to that mapped volume location, load the container named det/Ansible, which is my container image I built. Everything else is the command to run inside the container. This is the part you run if you're not using Docker. I have a subdirectory for this episode and the playbook is inside of that. Adjust this to your path and name. Okay, fire away. Excellent, Playbook ran successfully. Let's take a look at how this turned out. Scrolling back to the top. One note here about colors. I searched the internet far and wide, high and low, looking for a color palette that is neutral across all ranges of people's color vision. Did you know that there are 4 types of color blindness? I didn't either. So the color palette I chose has 5 new primary colors. Each of these colors should be visible with some amount of contrast in some form or fashion across all 4 types of color blindness and chromotypical folks. For those of you who may have a chromatopsia and only see shades of gray, send me a message, feel free to make it anonymous, and let me know if this output is visible enough for you. If you have any suggestions on how this could be made a bit more accessible for you, I will do everything I can to make it so. As it turns out, this particular color palette is actually quite nice and pleasant for chromotypicals, so it all works out nicely. First off is the play name. See? Name your plays. Next is the first task. Wait, what? Gathering facts? That's not our first task. What's this? Yes, gathering facts. Unless told otherwise, Ansible will always run its own built-in module to collect a massive amount of system information from the target host. This is actually some super nice info. System stats including RAM, disk, file system, network info, hardware info, storage controllers, Linux distribution and system OS details, lots of stuff. Date and time info in 8 different formats, all very nice. One caveat. This only works for a host using the SSH connection type or local loopback. None of this works with the HTTP API connection type, which is what we're using. These facts are completely useless to us. They're nice and noble, but useless. Yes, we can disable this operation, and we will for the next playbook run. So wave, blow a kiss, say goodbye, whatever, because this is the last time you'll ever see this task. Bye! Now our real task. See? Name your task too. You can see the target host used, which matches the inventory host in the CKP MGMT group. Even though the management group was specified, the group members were expanded for the task. The task status is okay. That must be a good thing, right? We'll see. Here's the next task. Again, task status okay, and the target host. Now you see the output. The first line of the output is host facts. That's the name of the variable whose contents were dumped by the debug module. Apparently, this variable is a dictionary, returned by the checkpoint host facts module. The next line is Ansible_facts. This is the first key in the host facts variable dictionary. It's called Ansible facts because that's the rule of all facts modules, which is set forth by the Ansible team. So what are these host facts? Well, it's a dictionary. The key is hosts, which is from the plural API command show hosts. Everything else inside this dictionary is the verbatim output of the checkpoint API command. Just for comparison, here's what the same API command returns when running it directly. Here I'm running the command locally on my management server with management CLI. Notice the output is the same. Look at your objects list here and you'll see the objects are returned in lexical order as well, just as they appear in the Objects Explorer in SmartConsole. Since this is the plural API command, we get the objects key and a list of host objects. At the end is the play recap. This section means exactly what it says. For every target host, it lists the stats of all the tasks ran for this playbook. If your playbook has multiple plays, you only get one recap for all the plays. This section really should have been written as playbook recap, but close enough, I guess. So far, you've only seen the OK status, but clearly there are more. What are these? OK is a good thing, sort of. Well, it's better than bad. OK just means the task ran, it did not fail. And that's okay. Changed means the task ran, it did not fail, and objects were modified to the specified parameters. Unreachable means the target host was just that, unreachable for some reason. Wherever in the play the host became unreachable, that's when it dropped out of the playbook. Any tasks executed on that host up to that point will be included in the recap. Maybe the host rebooted when the playbook wasn't expecting it, like one of those Gaia package updates, or the API server crashed unexpectedly. Failed means the task failed. No guarantees the object was or wasn't modified, however. This could be an inconsistent state depending on the situation and how the API server handled it. If you were doing something with the debug module or something else and you had a syntax error, then this will be a failed task too. Skipped means the task was skipped due to some conditional qualifier or flow control item. We'll see examples of these in the next episode or 2 or 3. Rescued is a special situation when you have a set of tasks that run as a group. If any task in the group fails, that failure can be picked up and handled gracefully without failing the entire playbook. For you Java or Python background folks, yes, this is exception handling. This would be the catch clause. We'll see examples of this as well when we get to some upper level routines later. Ignored means you added a task parameter telling Ansible to ignore the potential failure of a given task. You do this in cases where you know a task routine is likely to return an error and you plan on handling this error gracefully. This tells Ansible to look the other way when errors are tripped. Alright, that's your first playbook and demo. Okay, now let's change some stuff. But we'll throw it away at the end, so don't worry if you're not allowed to make changes on your server right now. Here's playbook number 2. I'm skipping all the stuff we already discussed. It's the same anyway. First 2 tasks are the same. The third task is new. This task calls a module with module parameters. For this example, I'm showing the levels of indentation for the task, the module, and the parameters. This is the specific checkpoint object module, not the facts module. Remember, an object module always requires, at minimum, a name parameter. Sometimes an additional parameter may also be required, but that is module dependent. In this case, when creating a new object, the host object module requires both a name and an IP address, just like it would in SmartConsole. In this example, I'm also adding a third parameter, just for illustration. Just like you do in SmartConsole, you can add all those same values, but here it's done in one task. Name, IP, color, comments, tags, groups, all those can be done as one operation, not 7 or 8 different clicks plus the OK button. The module will figure out if it needs to map to the add or set API commands. Even the state is assumed to be present. Notice what's missing, however. There's no register keyword. That's because an object module doesn't really return anything. Once again, each module is atomic. It does just one thing. If you want to see what it did, you have to do another thing. Or in this case, 2 things. These are the same 2 things you saw earlier. The first thing is slightly different. This is the host facts module as before, but this time it is given a name parameter to retrieve just one object, which maps to the singular API show host command. The result of that is again assigned to a registered variable. Even in the same playbook run, just as you might do manually, you can change your mind. Perhaps you meant to use a different object color. Yes, I know this is contrived and you never write a playbook this way, but I want to prove a point, which is you can change more than one attribute of an object in a single task, just as you can set multiple attributes when creating an object. Here the IP and the color are changed. For changes to an existing object, only the name parameter is required. The others are at your discretion. If you want to see the result as you go along, you do the same 2 things as before. Literally. The next task deletes an object. This is the object module again, which requires the name parameter. State is now absent, which maps to the delete API. Only the name parameter is required for state absent. For the next 2 things, since the object was just deleted, you can't get the facts for it. If you provide the object name as a parameter, the task will fail and not in a graceful way. So this task now maps to the plural show command. The second thing is the same as all the others. The last task is an interesting one. I keep making references to SmartConsole. Well, just like SmartConsole, you can discard everything you just did. So all of the operations in this playbook never happened. Just like SmartConsole, the API server opened a side session for the Ansible operations. Everything happened there. This is the end of the playbook. No explicit call to the logout command, just as there was no explicit call to the login command. The HTTP API plugin handled all of those housekeeping items for you. Let's see what this looks like at the terminal when it runs. Okay, calling an audible. I know, I said we never see the gathering effects again. This is the last time. For real, I mean it. Here's the first task, getting the host facts. It was the plural version of the API command, and many objects were retrieved as a list. Now, the host module was called to add a host. The task status is now changed. We didn't see that earlier. This meant something was modified in some way. Next, the host facts module was called. It was the singular version of the API command this time. Now the API returned just one object. Here are the details of that object. The dictionary keys, again, are in lexical order. We set the color to yellow, IPv4 address to 192.0.2.1, and the name is new host. Success! Now the host module is called again and made some sort of change. Okay, now checking with host facts, and once again, it was the singular version. Why? Because the name parameter was provided. Color was set to brown, IPv4 address was changed, just as we had specified. Next task deletes the host, and task status is again changed. What was the required parameter for state absent? Yep, the name parameter. So, was the object changed? Well, let's see. Host facts module is called again, and it was the plural version again, because why? A name parameter was not specified. Well, the object wasn't changed per se, rather it was deleted. So, a status of changed doesn't necessarily imply the object was changed, but rather some change was made to the object database on the API server. Lastly, the discard module was called Pop Quiz. Did we really need to call the discard module for this specific playbook? Yes, we did. Even though the playbook added an object, changed it twice, and deleted it, changes were still made to the session, just not the database. We have to discard or publish that session, or else it will remain open on the server's database, just like SmartConsole. Here's our play recap. The target host color is different than it was the last time we saw it. This color means the host had at least one task with a changed status. The recap summary shows 13 tasks were okay, only 4 tasks made changes. Final quiz. How many total tasks did we do? The answer is 12. One of these 13 tasks was the automatic gathering of facts. Yeah, I know, right? 4 of these tasks made changes, so 8 of them were innocuous. Why are the 4 changed tasks included in the list of OK tasks? Because they succeeded. Success is OK. There you have it, 2 fully working playbooks. Be sure to give a thumbs up and hit that subscribe button below so you know when new content is available. Please leave a comment to let me and others know how this video helped you. I'll see you in the next video where we'll dig more into Ansible variables and get into loops.